be tomorrow. 48 to 55 will be next week. 56, 62 will be the third week. Then we'll move to engine performance. That's our last block of chapters for the class.
Wait a minute, so we're testing for 39 to 47 tomorrow?
Yep. We sure are.
Why?
We lost a day.
Because we had to give up a day for
I know.
the other one. I'll make sure you're prepared. All you gotta do is pay attention and do your part. Okay? If you're sleeping or you're daydreaming or whatever, you're not gonna pass. That's the bottom line. Okay?
I can't see that. What is that, 48 to what?
48 to 55,
Thank you.
and then 56 to 62. Okay, this first chapter, 39, some of this you should be familiar with from school, hopefully, right? Do they teach this in school?
Yeah.
At least I'm pretty sure they do. I haven't been to school in a couple of years, but do they teach that?
Electricity.
Electrical stuff, a little bit of science, you know, atoms, you know, electron flow, stuff like that? Yeah? Okay. You should be a little bit familiar with this. Okay. As we go through this, I'm going to help you out a little bit. And when we get to certain parts, I'm going to tell you the things that you need to write down or remember, okay? Why would you do that?
So we can finish that.
Because it's going to be on the test. Okay? I said all you got to do is pay attention and you'll be all right. Okay? Okay, let's go through 39. Again, some of this should be familiar to you. We're going to go through the fundamentals of electricity, how electrons move through a conductor, units of electrical measurement, relationship between volts, amps, and ohms. Anybody familiar with Ohm's law? No? No?
No.
Okay. You will be by the end of the day. We go through different sources of electricity, conductors, resistance, function of resistors. Anybody know what a resistor is?
No.
No?
Something that stops the flow of electricity?
Okay, kind of, yeah. It's found in every electronic device in the world. Okay? Basically just a electronic device that will impede or resist current flow. Okay, that's what they call it, a resistor. All right? Electricity may be difficult for some people to learn for the following reasons. You can't see it. Only the results can be seen, has to be detected and measured. The test results have to be interpreted. It's not that hard though, okay? Electricity is the movement of electrons from one atom to another. You might want to remember that. You know what I mean? You might want to remember that. The term describes the movement of electrons from one atom to another. Answer: electricity, okay? If you don't have a notepad, you should have had one from day one. I told you you should have a notepad and something to write with so you can take notes. You can write in your book if you want to, but that's something that you're going to need to know, okay? Should have had a notepad long before now if you don't. Dense center of each atom is called the nucleus. It contains protons and neutrons, which you should be familiar with. Protons have a positive charge, neutrons are neutrally charged. How about Charles? You familiar with any of this? Did you read chapter 39 or 40 maybe? A little bit? None? None? Okay, you familiar with electrical fundamentals at all?
Yeah.
A little bit? Okay. Okay. Magnets and electrical charges. An ordinary magnet has two ends, north and south pole. Everybody should know that, right? Like poles repel, opposites attract. When an atom is not balanced, it becomes charged. A charged particle called an ion. Electron shells. Let's see. You missed the part a minute ago where I'm gonna tell you what's gonna be on the test as we go through this. Okay? Make a note of it. What describes the term of electrons moving from one to another? What do they call that? What term describes the movement of electrons from one atom to another? Here's the answer. Okay? Okay. The only one you missed. On page 454 under definition of electricity, you'll see that. Might want to write on the book, something like that. You'll see this later, okay? Valence ring is 3 or less electrons. It will attract free electrons. Valence ring with 5 or more electrons will tightly hold electrons. Okay, some of this stuff you don't really know too much about, but these you do, okay? What is a conductor?
Conducts energy.
What's that?
It conducts energy.
Electricity.
Okay. Material with fewer than 4 electrons in the atom's outer orbit. This is not something you got to worry too much about as far as that goes. The conductor is basically anything that will conduct electricity. Okay? A wire is a conductor, right? Copper is a conductor, silver is a conductor, gold is a conductor. Anything that will conduct electricity, okay, is a conductor. Insulator, just the opposite, right? An insulator will not conduct electricity. Give me an example of an insulator.
Rubber.
Okay. Rubber is one.
Styrofoam.
Okay. Wood, plastic, you know, anything like that. Anything that won't conduct electricity is an insulator, okay? Semiconductor has exactly 4 electrons in the outer orbit. Either conducts, it's neither a conductor nor an insulator. We call that a semiconductor. Okay, we're not going to go through all of these little examples here. You can see that in the book. Nucleus of an atom has a positive charge. Some of this you should remember from school, hopefully. Balanced atom, same number of electrons and protons in the nucleus. The magnets you should be familiar with, north and south poles, right? What's the outer electron shell known as? You're going to need to know that. You're going to see that, okay? What is it?
What did you, I'm sorry, what was the question? I'm reading and.
The outer electron shell is known as what?
The balance ring?
The valence ring? Okay. Okay. Again, we're not going to go through every one of these little things because this is something you're not going to remember anyway. Just the basics, okay? As the number of electrons increases, they occupy increasing energy levels that are farther from the center of the atom. Conductor is any element that has 1 to 3 electrons in the outer orbit. Copper, excellent conductor. What is most of your wiring made from in your car?
Copper.
Copper.
Okay? And the insulation over it, the plastic over it is the insulator part, right? Keeps the wires from conducting, touching each other, shorting out, right? Okay. All right. Insulator, element with 5 to 8 electrons in the outer orbit, would not conduct electricity. We talked about the semiconductor, it has exactly 4 electrons in the outer orbit. Okay, as far as test questions, those are the ones that I told you about already, is all you're gonna see, all right? As far as this goes, okay? Okay, tell me what this is.
It's the movement of electrons from one atom to another.
Perfect, good job. Okay, current flow. For current to flow, there must be an imbalance of excess electrons at one end of the circuit and a deficiency on the opposite end of the circuit. Conventional theory versus electron theory. Conventional theory, flow of electrons from positive to negative. Which one do we use in the automotive industry? Do we use the electron theory or conventional?
Convention?
Okay, we do. Conventional theory says electrons flow from positive to negative. Since there's 2 theories on this, that tells me nobody really knows. Some people think it's one way, some people think it's the other way. Who knows, right? You can't see it. We talked about that a minute ago, right? You can't see it, you can only see the effects of it, and you can test it. Okay? Current electricity movement of electrons through a conductor. Conventional theory states that current flows from a circuit from positive to negative. Automotive electrical uses the conventional theory in all electrical diagrams and schematics. So whenever you see an electrical diagram or schematic, typically at the top you're going to see the power flow, at the bottom you're going to see the ground. It's going to tell you that the current flows this way. Okay? Positive to negative. What is an amp? This is the proper term, but we just typically call it an amp, okay? Ampere is the proper term, but we typically don't use that, okay? When somebody refers to current, they refer to it in amps. Okay? Question? No? Volts. Unit of measurement for electrical pressure. This is Ohm's law. I put this up here a minute ago, right? What is E over IR? Anybody know?
Electricity over 1 resistance.
Okay. E is for the voltage, okay? Or the electromotive, or the electrical force, okay? I is the current flow, measured in amps.
It's an I?
R is resistance.
It was
Okay.
a 1.
What's that?
I thought that was a 1.
Okay, sorry, it's an I. There, how about that? E equals I times R, or you could rearrange that any way you want, and it comes out with the same. So when we go through some electrical diagrams and schematics and stuff like that, we'll see how that Ohm's law works, okay? The other term you're going to be familiar with, it uses the omega symbol. That is a symbol for ohms, okay? Yeah. Ohms, resistance to the flow of current through a conductor, measured in units called ohms, okay? This is the guy. This is Ohm's law right here. What is the electrical unit for power? You're going to need to know that. Okay? Watt is the electrical unit for power, the capacity to do the work.
You mean watt? Are you talking about watt?
What?
The capacity to do it, is that what you're talking about?
Mm-hmm. It is in order to calculate the wattage of something, you would take the current times the voltage, okay? We don't need to worry about that. Okay. If you're gonna measure current flow, you need a thing called an ammeter. You need to pay attention to the spelling because this question is gonna be on the test. There is no P, okay? It's called an ammeter, not an amp meter, okay? Got that? Okay. And it measures current flow. Voltage is the electrical pressure that causes the electrons to flow through a conductor. Voltage is the pressure, okay?
Can you repeat that, please? What you just said word for word.
Which part are you talking about? Voltage is the electrical pressure that causes electrons to flow through a conductor.
Oh, okay.
Okay, voltage is the pressure, all right? The ohms or the resistance is the resistance to this current flow. The amperage is the actual current itself. This meter should look familiar, the same one on the table there. This can read just about anything as far as amps, volts, ohms, anything like that. This is set to read DC volts. It's hooked up to the battery in our car. It says 12.6. Is that right? Is that about right for a car that's not running?
Yeah.
Engine that's not running, right?
Yeah.
That's normal battery voltage, right? If you have a good battery.
Yeah.
Okay, we've been through that before. That's called open circuit voltage. Okay, your resistance to the flow of electrons is measured in ohms. So remember, the voltage is the pressure, the resistance is, I'm not letting you through there. Or maybe only a little bit of you, okay? With resistance, more voltage is required to push electrons through the circuit. Okay, we've been through this, I think. No, we haven't been through alternators yet, have we?
No.
Okay. So your alternator on your car generates an AC current, okay? That's basically how it works right there. And as you know, AC does not work in cars. It has to be converted to DC. It's converted inside the alternator itself through a series of diodes called a rectifier bridge. It will convert this AC that the alternator actually generates to DC so your car can use it, right? This is a hand crank generator at the museum. Okay, sources of electricity. Let me see if there's going to be something for sources of electricity on here. There's a test question where you're going to have to calculate wattage. You know how to do it? It's on the board. How do you do it? How do you calculate wattage?
I times E equals W.
E times R, voltage times current, right? Okay.
You said E times R?
No, I times E.
Ah.
Current times voltage.
I is current, right?
Yes,
I thought I was amp, oh, never
it
mind.
is.
Okay, yeah.
Current is
I'm
measured
sorry.
in amps.
Yeah, it's the,
Okay,
E
The
is
word,
voltage.
sorry.
so let's do this.
W is watts.
measured in
But if
ohms.
y'all don't do, I'm still gonna do it myself.
All right, sources of electricity. Let me see, I think there's a question on sources of electricity. There's also a test question where you're going to have to calculate how many amps will flow in a circuit. It's going to give you the volts and the ohms, and you're gonna have to calculate the current flow, okay? All right. Source of electricity. Friction is one source of electricity. When certain materials are rubbed together, friction causes electrons to be transferred from one to the other. Heat. Two different metals are joined together. Both ends at one junction is heated. Current passes through the metal. Light is another source of electricity. When certain metals are exposed to light, light energy is transferred to the free electrons of the metal. And then pressure, the generation of voltage due to pressure applied on a crystal or to a crystal. There's going to be a test question that asks about this. What is this guy right here? We looked at this before?
No,
Anybody remember what this was, or did we not look at this?
no, we haven't.
This is a knock sensor. All cars have knock sensors. What does this do? Anybody know? No? What's that? Senses voltage?
No.
Okay, this is an example of a voltage being able to be created by pressure. Okay? So what we're going to do is we're going to let you see it in action. Okay? This is going to generate an AC voltage. Okay? I'm going to put the meter on AC volts. Okay? This is the terminal right here that's going to go to the wire to the computer, right? So we're just going to put this right here. This is the ground. This is screwed into the engine block cylinder head, something like that, right? So I'm just going to ground this one. And then we're going to take this and we're going to go, okay? This is generating an AC voltage just by putting pressure on here.
Oh, that's what geoscientists do.
This is what happens when your engine makes a knocking noise, a spark knock, some abnormal combustion, okay? It picks this up. Sends a voltage to the PCM and it says, this engine's knocking, we gotta fix it. So what does it do to fix that? Because that will destroy an engine after a while, right? What does it do? It does what? If it does it for long enough, it will. What does it do to correct it? We talked about it yesterday. It has to do with ignition timing.
Slow it down.
Remember that? First thing it's going to do is retard the ignition timing to try to get rid of that. Okay? It will do whatever it can to try to get the engine to stop spark knock or pinging. Okay? Because that will destroy an engine after a while. That's what the knock sensor does. That is an example of being able to generate a voltage by putting pressure on a crystal. Okay? Chemical is another source of electricity. Two different metals placed in a conductive reactive solution creates a difference in potential voltage between them. This is the exact kind of example of your battery, right? Electrochemistry. Magnetism, if a conductor is moved through a magnetic field or a moving magnetic field is moved near a conductor, that will generate electricity as well. This is the one that's showing you how you can generate electricity. Weak electrical signal.
Do we need to know conductor ratings for the different, metals? Or that maybe on an A or something? Like silver and lead and
No,
zinc?
no.
Okay.
No. All you really need to know is copper is the most common one used. The only time they use gold in cars is on airbag stuff, okay? All of your connectors for your airbag are gold plated, okay? Because gold doesn't corrode, it doesn't tarnish, it doesn't go bad over time, right? You don't want a problem with your airbag connections, so they're all gold, okay? And the wiring is yellow, okay? It's gonna be covered with a yellow conduit to let you know that's airbag wiring, okay? Electron flow is produced by light striking a light-sensitive material. This is like a photocell, photodiode, something like that, phototransistor. So you're gonna see the light hitting this, and then you're gonna see an actual current flow on this ammeter. This is the example of the knock sensor that I was just showing you. It's applying pressure on the crystal, creating a voltage. You got to see that on the meter, right? Six sources of electricity: friction, heat, light, pressure, chemical, and magnetism. All right.
We won't need to know, like, or it won't be on the ASC of the, resistor color code or anything.
Nope. Nope. Resistors are color coded to tell you what their value is. Normally I have some here and we kind of look at those, but you can calculate a resistor's value by the colored stripes on it. Tells you that there's a chart in that for that, but you don't have to worry about that, okay? You don't need to know that. You do have to know this: conductors and resistance. All conductors have some resistance to current flow. If the conductor length is doubled, the resistance doubles, okay? If you have a 3-foot piece of wire and you measure the resistance of it, and then you take the same type of wire 6 feet long, the resistance is gonna double, okay? If the length is doubled, the resistance doubles. If the conductor diameter is increased, resistance is reduced. So what does that mean? Tell me what if the conductor diameter is increased, the resistance is reduced. What does that mean? What's the biggest wire on your car?
Terminal.
The biggest diameter wire on your car, any car.
That'd be like the wire that goes to the terminal of the battery.
Battery cable,
Yeah.
right? It's got the largest diameter, it has to carry the most current, it needs the least resistance, okay? What's the highest current draw on your car? What component produces the highest current draw on your car?
Alternator.
It produces current. I'm talking about what uses it. What takes the most current in a car?
Lights. No.
It's the first thing that happens when you get in your car.
Starting the car?
The starter, yeah. The starter will draw, depending on the car, maybe 150 to 250 amps, okay? So it takes to crank that engine over. So your battery cables are so big, okay? If you put small battery cables on a car, first thing that happened when you went to start the car, it would melt the wires, and the car wouldn't start. Okay? As the temperature increases, the resistance of the conductor also increases. Materials used in the conductor have an impact on its resistance, obviously. You can see that from the chart. It tells you what type of metals are good conductors. Again, you don't really need to know this, but it's a good idea, have a good idea of what the first 2 or 3 are, okay? Why is gold used if copper has a lower resistance? Well, we talked about that already. Gold is used in airbag connectors and some sensors because it does not corrode. Gold can be buried for hundreds of years, and when you dig it up, it looks just like it did before. Okay? You ever see the movies where they find all this gold, and it looks all brand new? That's the way it would really look. Okay, what's the relationship between the length of a wire and its resistance?
How much voltage it needs to go through?
Okay. As the length increases, if you double the length, the resistance doubles too, right? Okay? So if you had let's say you relocated the battery in your car from under the hood into the trunk. You'd have to have a lot longer battery cable, right? So the resistance of that battery cable gets more as the length increases, right? So you have to have a heavier or larger diameter cable because of the distance it has to go.
I have a question for the battery. So if you keep it in the truck, can it last longer if it was in the engine?
No, it lasts longer if it's not under the hood. The cars with batteries that are inside, passenger compartment or in the trunk, typically last another year, sometimes 2 years longer. The reason is they don't have to put up with the heat under the hood. Heat's one of the things that kills batteries.
Is that why a lot of drift cars relocate their batteries in the trunk?
They do that for weight distribution
Oh, okay.
more than life, yeah.
Okay.
All right, a fixed resistor. That is a resistor that has a resistance to electrical current flow, and it is what it is. Let's say you have a 100 ohm resistor. It's a fixed resistor. This doesn't change. Okay, it might vary just a little bit depending on heat, stuff like that, but it is what it is. The variable resistor is what? These are two things you have to know. You better write those down, take a picture of them, whatever you want to do, you're gonna have to know them. If you miss these questions, it's not my fault. I'm giving you the best chance you can possibly have, okay? Variable resistor potentiometer is a 3-terminal or 3-wire variable resistor. The rheostat is a 2-wire variable resistor.
You said the rheostat?
Rheostat is a 2-wire. Potentiometer is a 3-wire.
The potentiometer, we learned about that in the other chapter.
Give me an example of this.
3-wire.
Potentiometer?
Give me a good example on your car. Every car has it.
Audio, radio. Speakers.
Closer to this. Like a volume control radio would be more like a rheostat type of thing. However, you're getting close. A good example of this is your throttle position sensor. 3-wire potentiometer, okay? You may see that later too.
The potentiometer is 2 or 3 wires?
3-wire. Okay.
You said the potentiometer for the throttle?
Throttle position sensor is a good example of a 3-wire variable resistor or potentiometer. Okay? Rheostat, 2 wires. Potentiometer, 3 wires. They're both variable resistors, okay? Okay. You don't really have to worry about the resistor chart. You're not going to have to know this, but this is what a regular old carbon fixed resistor looks like. They have color-coded stripes on them. Each one of those stripes represents a number. Chart's right here, okay? First 2 represents the numbers. This is the multiplier. So let's say you had a brown and a green. It would be 15, and then the multiplier, whatever that happened to be. If this was, just tells you how many zeros you would put after that 15. So if it was a 1, this would be a 150 ohm resistor. If it was color-coded like that, all right? Again, you don't have to worry too much about that, but that's what a typical fixed carbon resistor looks like.
It looks like a piece of wood.
Okay. 3-wire variable resistor, we just went through this. It has a reference voltage, a ground, and then a signal wire. if this was a throttle position sensor, we could call this your 5-volt reference. That's usually what they use. This is your ground wire, and this is your signal wire. Depending on where this arm is, let's call this your foot on the accelerator, okay? As you push on the accelerator, it's gonna move this arm in this potentiometer, okay? And as it moves, this signal voltage changes. If you're not touching the accelerator pedal, if the engine's just idling, it's typically a 1/2 volt, okay? When you have your foot all the way in it, it's about 4.5. Never really reaches 5, but, okay? And if you're halfway in it, you know, 2.5. You get the picture, right? Okay. So far, so good. Make sense? Rheostat kind of works the same way. It's just 2 wires. You have your power source and then the output terminal. It also has a movable contact in it. Typically, those are used in temperature sensors. Okay. Not going to go through that, and we should be through this one.
Good.
What's that?
You good?
Yeah, I dropped this, it hit my foot and rolled all the way under there, so. I got it though. You okay back there?
Yeah.
You getting it? Okay. You're gonna have to at this point. You gotta survive the rest of this class. It's gonna take some extra hard work for everyone. Might want to make a note on your quiz that you're doing right now, that question number 1 is question number 1 on the test tomorrow. Okay? Make sure you get it right. This is the example of the knock sensor we talked about and showed you, right? What's the answer to this one?
Piezo.
Piezoelectricity, yes. Okay. We're giving you number 1. And it is going to be number 1 on the test.
Yeah,
Yeah.
B. Yeah. Do you know number 4?
Positive charge ion. I believe it's neutron, but don't take my word
I
for
think
it.
it's none of them.
I think it's like ion.
Ion
Let me see.
is unbalanced. And therefore has a positive charge.
Hmm?
Yeah, it's like the second sentence.
Oh yeah, that would be a proton, so none of these.
Ion.
For 4, it'd be none of these. It says on 454, protons have a positive charge.
An ion says when an atom loses any electrons, it becomes unbalanced. It has more protons than electrons and therefore has a positive charge.
Okay, I forgot about ion, just because I actually went there. You find 3?
3 is less than 4. That's on 455. The very first sentence on conductors.
I think 5 is A. Would be the only thing that makes sense.
Yep.
Least resistance.
Least. Solar? 6. Like, are you on number 6?
Yeah.
You see this chart right here?
Mm-hmm.
Is this like the least?
Oh shit, yeah. No, it's 500. So that'd be silver.
But silver is number 1, starting with the best. Conductor rating starting with the best, so silver would be the best.
Fuck. Tungsten is not that good. I guess it could be pure fucking metal. Have the least resistance. Then again, it does make sense for lead.
But The options are silver, gold, and
I
copper.
know, I'm just saying at the bottom from these are best of these.
He said gold can last forever, right?
Yeah. Copper.
So I guess
Oh,
so.
that's probably why he said remember the first three.
Yeah.
So yeah.
Which is the least? Silver.
Gold. Starting with the best. 1, 2, 3.
The question is, which of these elements has the least resistance?
What's the least resistance?
Silver.
I guess silver's number 1, right? What it's saying is copper is better than silver, gold is better than copper.
Silver has the, yeah, right there. Silver has the lowest resistance among all materials used as conductors. Stuff looking
Okay, should have plenty of time to do that. Hopefully. Yeah?
2. I'm on the back of the
2
page.
more minutes.
Not done?
Confused.
All right.
Usually has how many words? 2. What term describes the movement of electrons from one atom to the other?
Definition.
The outer electron shell
Valence.
is
It's on 455.
the valence, right?
Hmm?
It's the valence, right?
Yeah.
I'm good.
All right, let's do it.
Creating electricity by exerting force on a crystal is called piezoelectricity.
And it's an example of a knock sensor, which we just saw. Okay. Don't miss this test question. Give you the heads up. I'm doing the best I can. Automotive battery using principle of what?
Electrochemistry.
Electrochemistry. Okay. Sorry, I took your question from you. Charles, take 3.
Electricity conductor is an element with less than 4.
Okay. Less than 4.
A positive charge, an ion.
An ion. There you go.
Most carbon resistors indicate their electrical resistance by color-coded markings.
That is correct.
Which of these elements has the least resistance? Silver?
All right.
What type of material is indicated by this atomic structure, insulator?
That is an insulator, yeah.
A rheostat usually has how many wires? 2.
2 wires, okay. See how easy this is?
What term describes the movement of electrons from one atom to another? Electricity.
That one's gonna be on the test. Yes, it's electricity. So is number 10. Might wanna make a note of it on your quizzes.
I thought number 10 is a valence ring.
It is, okay. All right.
He's saying it's gonna be on the test.
What's that?
No, it's somewhere that he says it's gonna be on the test.
Number 9.
9 and 10.
For number 9, they weren't looking for friction or static electricity, just electricity.
Yeah, it's on page 454.
Yeah.
I know it's on page 458, but I said none of these because I was looking for the exact word.
It's just the definition of
Yeah.
electricity.
Yeah.
Electricity
Movement of-
is the
Yeah, I
movement
know,
of
but
electrons
what
from
I'm
one atom to
saying
another.
is static electricity is different from just electricity. You see what I'm saying? Like it's
Yeah, well, we
literally
went through different sources of electricity. It was just talking about electricity itself, and the movement of atoms from one electron to another, or one atom to another. Okay, we did number 1. This is the question that's gonna be on the test. Okay? Okay.
Technician A says 2-wire variable resistor is called rheostat. Technician B says that 3-wire variable, yeah.
Oh,
The outer
Okay.
electron shell is known as valence ring.
Okay, this one's gonna be 2.
What type of sensor?
A?
Knock sensor?
Oh no, A and B.
They're exerting
The
force on a
fact
crystal.
that voltage.
Yeah, knock
What
sensor.
number are you on, 5 or 6?
Five.
5.
It's gonna be on the test.
Which device produces electrical current resulting from the heating of two dissimilar conductors? Thermocouple.
Thermocouple is correct.
Which of these is also known as electrical potential?
Potential. It's between volts and amps.
See?
Mm-hmm.
How? What? Oh,
Volts.
I heard him say C.
He said volts right after. Right before him. Electricity moving through a conductor produces a magnetic field. This principle is used in which of the following?
Oh.
Ignition coil?
What's that?
Oh.
Yes, sir.
I didn't
It
see
is
that.
all of them. Electricity moving through a conductor produces a magnetic field. This principle is used in ignition coils, starter motors, relays, all of that stuff. Okay, it's on the board. How do you calculate wattage?
Multiplying
Dividing and multiplying.
amps times
Oh,
volts.
Amps times volts equals watt.
Multiplying volts by current.
See?
Okay? Yes.
So we
Multiplying volts by current. A.
The
Be a bad
automotive-
idea to remember that one too. Automotive battery.
We already did that one.
Example of principle of electrochemistry. All right.
Can you do the book? There's a couple in there we haven't done.
Okay.
Two, 3, 4, 5.
All right.
2 to 5, I don't think we did.
Like charges. How do like charges do?
Like
Track.
charges repel each other.
They do, yes. Electrical conductors, an element with less than 4, so B for number 1, B for number 2. Carbon and silicon are examples of what?
Insulator.
Semiconductors.
Semiconductors, yeah. Which unit of electricity does the work in a circuit?
Mm.
The amp does the work, yep. Which one is the unit of electrical pressure?
Volt.
The volt, okay. We did 5, that's B. We did 7, that is knock sensor. As temperature increases, what happens?
You met at 6?
We're on 8.
6 is B. He said 5, but he meant to say 6.
Did I?
Yeah, you said 5, B, 7. Knock sensor.
the resistance of the conductor decreases.
As temperature increases,
The resistor increases.
As temperature increases, what happens to the resistance of a conductor?
Decreases.
It also increases.
Yeah.
the resistance, is it A?
Heat is resistance, okay?
It's A. Right?
B.
No,
Oh.
8 is B. As temperature increases, the resistance of a conductor increases. You crank your car too long and the battery cables get hot, the resistance increases, it's not gonna crank as fast, right? Car gets hot, cables get hot, temperature is directly related to resistance. Okay, we did 9, that's both of them. And 10 should be obvious, I used that as an example
A.
earlier. Okay. go through a little bit of electrical circuits and Ohm's law.
On the tennis game,
What's that?
number 4.
Yeah.
Everybody got all those? Nobody's lagging behind, right? Okay. We're gonna identify the parts of a complete circuit, the characteristics, different types of circuits. Ohm's law as it applies to automotive circuits. Okay? You got it? Watt's law as it applies to automotive circuits. That's pretty basic, it's right here. Okay? This is going to be part of content area A for your ASC A6. Our last ASC is going to be A8, which is engine performance. Okay? We'll spend the last 3 weeks on that. Definition of a circuit. A circuit is a complete path that electrons travel from the power source, such as the battery, through the load, which happens to be whatever it's powering, such as a light bulb, back to the power source. Okay? Parts of a complete circuit, you gotta have a power source, some sort of protection. That's gonna be what? Fuse, right? Fuse or fusible link, circuit breaker, something like that. That's your protection. Without fuses, if you had a short in the wiring in your car, it would probably end up catching on fire. And that'd probably be the end of your car. It has to have a path to get to the power, get the power to where it's going. It's got to have some sort of electrical load and a return path to the battery.
She sent me a text, I want them up,
Such as this.
so I didn't come in there.
All complete circuits must have a power source, a power path, protection, electrical load, and a return back to the power source. Okay? We use positive to negative, right? First thing you're gonna get after you get your power source, some sort of protection. It's gonna go through the fuse, okay? Then it's gonna power whatever it's powering. This happens to be just a light bulb in this case. Back to here. That's a complete circuit, right? Is that light bulb gonna light if that's hooked up and this battery is good?
Yeah.
Yep, right? If this fuse is blown, is this light gonna light?
No.
No, because it has to go from there to there, right? Any interruption is going to make it not work. If you have a bad connection here, it's not gonna work, right? If you have a broken wire here, it's not gonna work, right? What if this wire got shorted to a ground source somewhere in your car?
Shorted to a ground source?
Yeah, what if this wire was grounded? What if it got shorted out on the frame or something metal on your car, which is also a ground, okay? Everything metal on your car is a source of ground too, okay? Because your battery cable goes to the engine block and then to the body, okay? So what would happen if this wire got shorted to ground?
Would the light be dim?
Blow up.
Absolutely nothing would happen. It's grounded here, right? If it was grounded here, who cares, right? Light's gonna be on all the time. What's wrong with this circuit? What's missing here? What's missing there is there's no switch. Okay? There's nothing to turn that on and off. It's just giving you an example of what a complete circuit looks like. So, if you ever really had something hooked up like this, obviously this bulb would be on all the time until it drained the battery, right? Okay. Like I was saying, body, sheet metal, engine block, anything is also ground. So, if this went from here and it was just, this bulb was just grounded to the body, some sort of sheet metal, engine block, something like that, still gonna work because your negative battery cable is gonna go there, okay? So all the metal on your car is a ground path, okay? There you go. Now we got a switch there. Is this light bulb on or off? It's off, right?
Yeah.
Because the switch is open. This is called an open circuit. The current's gonna go from here to here, and then it's gonna just hang out and do nothing, right? Until you hit this switch, and then the light comes on, right? It's like when you turn a light on in the room, right? Okay. Make sense?
Yeah.
Okay. What is included in a complete circuit? Gotta have a power source, some sort of circuit protection, power path, electrical load, return to the battery. Okay? What is an open circuit?
When it's not connected.
When it's not closed.
An open circuit is any circuit that is not complete or lacks, this is the word you gotta remember,
Continuity.
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 Okay? That means you have a connection from here to here, okay? There's a test question that's gonna ask you that. Make sure you use this word, because there's words that are similar to that that are trying to confuse you, okay? Continuity is the word you're looking for. Short to voltage, that is when the power side of one circuit is electrically connected to another, unintentionally. Short to ground is a type of short circuit that occurs when current bypasses part of the normal circuit, flows directly to ground. What is going to happen if you have a short to ground on a circuit in your car? What's going to happen? What's the first thing that's going to happen if you have a short to ground on any circuit in your car?
It's not gonna work.
What's that?
It's not gonna work. It's not gonna.
How come?
It's shorted.
Okay, but what's going to happen? What's the first thing that's going to happen?
Spark.
Are you gonna get a signal on dash?
Nope. Current's going to bypass part or all of the circuit and flow directly to ground. So what's the first thing that's going to happen if you have a short to ground?
Is it gonna come from somewhere else?
What are these?
Fuse gonna pop.
Fuse is going to blow, right? Keeps the car from catching on fire, right? It would melt wires, start a fire. That's why you have fuses, okay? First thing that's going to happen if you have a short to ground, it's going to blow that fuse and that circuit is no longer going to work, okay? Whatever it happens to be. High resistance is any unwanted resistance or load in a circuit. Did you have a question?
Yeah,
Okay.
but it's on a pass line. Continuity. You said it was what again?
Continuity?
Yeah.
That means you have a connection from point A to point B, okay? That means it has continuity. Let's say you take a meter, put it on the ohm scale, and you want to check to see if there's continuity between this wire and this wire. That's what you're checking for. Is there a connection between these 2 points?
Oh, yeah.
Okay? Common examples of open circuits. Some of these causes are often difficult to find. Broken wire, long fuse, corroded, loose connection, stuff like that. Those cause high resistance, sometimes cause open circuit, okay? Short circuit permits electrical current to bypass some or all of the resistance in the circuit. What's going on here?
It looks like a detour.
One switch is open, one switch is closed.
Okay,
It's going around it.
so here's what's going on.
That open switch isn't connected, so it's going
You-
to the closed switch.
You have 2 bulbs, 2 switches. This switch works this bulb, this switch works this bulb. If you look at the diagram, both of those bulbs are lit,
Yeah.
but this switch is open. How is that possible?
That one goes around and connects to the top.
What's that?
It goes to the top.
Short
It's
voltage.
borrowing power.
Yeah, you got to short the voltage. This wire is shorted to this wire, so now this bulb has power too. Okay? That's just an example of a short to voltage. You have one power wire unintentionally touching another one. That causes something to work that's not supposed to be on. So let's say you have a problem with your car where you turn your turn signal on and your brake lights come on. or you turn your headlights on and your dome light comes on. You gotta short the voltage somewhere. It's powering a circuit that's not supposed to be powered. Okay?
Oh, okay. Well, then what's going on? Perfect, thank you guys.
Fuse or circuit breaker is your protection, keeps the overheat damage from short circuit. Okay, it can be a circuit breaker, it can be a fuse, it can be a fusible link. Fusible link is just a piece of wire that's designed to melt at a certain current flow. Does the same thing as a fuse does, okay? Short to ground affects the power side of the current. Current flows directly to ground, bypassing some or all the electrical load. So, here is your circuit, right? Just a bulb, switch. You hit this switch to turn on this light, and for some reason, this wire is shorted to ground. The current's gonna do this, right? It's gonna bypass this. It's gonna take the path of the least resistance. It's not gonna go through that bulb, because it's gonna say, this is too much trouble. Electricity's lazy, right? Takes the path of the least resistance. So what's gonna happen? Too much current's gonna flow in this circuit, and that fuse is gonna blow. If this fuse was not here, it would be like connecting your positive and negative battery cables together. What's gonna happen? Spark. Yeah. Huge spark, and then the wires are gonna get so hot, they're just gonna start a fire. Your fuses are what keeps your car from burning down if you have an electrical short. Okay? Important part of your electrical system is your fuses.
So if the fuse blows, that means something's wrong with the wiring on that.
If you have a blown fuse, that means you have a circuit that is flowing too much current. You have a short somewhere, or you have too much electrical load in there, or I should say not enough. So, another thing you gotta remember is, if you have something that doesn't work on a car, first thing you do is check the fuse, right? Okay, if you find a blown fuse, replacing the fuse is not a fix. That fuse blew for a reason. The new one's gonna do the same thing. Might not do it as soon as you plug it in, but it's gonna do it. Okay?
Well, are we getting a warning from the dash if the fuse blows?
What's that?
Do we get a warning on the dash if the fuse blows?
Typically not.
How would you know if the fuse?
Something's not gonna work. Let's say you get in your car and you turn the radio on, the radio doesn't work. That's weird. Well, let me check the radio fuse. Right? First thing you're gonna do, right? Or your lights don't work, or whatever, okay? What's the difference between short to voltage and short to ground? Will a short to voltage cause a fuse to blow? No, short to ground will, right? Okay. So let's see, what's the difference? Short to voltage in the power one circuit is unintentionally connected to another, like we saw in the diagram. Short is when short to ground is part of the circuit that bypasses the load and goes to ground. I use an example here of a water wheel to tell you kind of how electrical flow through a circuit is similar to that. The more water or amps electricity, the greater amount of work that can do. Shows you the 12 feet of potential energy. They're using that as an example of how electrical flow works. Okay, you're gonna need to know this too. This is the definition of Ohm's law. It requires 1 volt to push 1 amp through 1 ohm of resistance. Okay. That is on 465 under Ohm's law. You might want to highlight that or whatever. Requires 1 volt to push 1 amp through 1 ohm of resistance. Formula. This is the formula. The good part about that is if any 2 of these are known, you can figure out the other one.
So the E over 1, or I times R is for this?
That is Ohm's law, yep.
Okay.
we'll do some circuits and you'll see how it works. And you'll have to do a little circuit solving on the test, but it's gonna be basic and easy stuff, okay? It's simple math. You're not gonna have to know any high-powered math, okay? I'm gonna show you how it works. This circuit has 12 volts, right? So 12 is your E, right? So let's do this, 12, right? The bulb is 4 ohms, that's your electrical load, right? 4 ohms of resistance, right? So what would the current flow be through that?
3.
Very easy, right? 3 amps, right?
Division.
It's honestly simple math, okay? 3 times 4 equals 12. You could do it this way too, right? Because you have your I times R, right? This is your I, this is your R. 3 times 4 is 12, right? Ohm's law, you can figure out any electrical circuit, resistance, current flow, or voltage. If you know 2 of them, you just use that formula. If you have a 12 volt battery and a 6 ohm light bulb, how much current's going to flow through that circuit?
72. 6, so 6 divided by 2, never mind. I was multiplying that.
Again, here's your 12, here's your E, right? And what is your resistance? 6, that's going to go underneath it.
Me too.
It's 2 amps, right? 2 6s is 12, right? It doesn't get any simpler than that. Hopefully you learned this in school. Okay? Anybody not understand that? How about you?
I got it.
You got it? You got it? You sure? Okay. If you didn't know the resistance of this circuit, 12 volts, 3 amps, how many ohms is that bulb?
4.
Has to be 4, right? 3 times 4 is 12, right? Okay. See, it's not as scary as it looks, right? Everybody got that, right? Hopefully?
Yes.
So, obviously, these are simplistic circuits. They're just trying to show you how Ohm's law works, right? So, normally this would have a fuse right here, right? If that circuit, you knew it was only going to draw 3 amps when it was operating, what fuse would you put in there? What size fuse would that circuit have?
Small.
If this circuit only draws 3 amps, let's say you were designing this circuit or adding something to your car or whatever, putting something together, what size fuse would you put in it? 3? Okay, that would be right on the borderline of melting it.
Wouldn't it be the same size?
So the fuse has to be
A lot more.
10, 15% higher than the actual circuit, right? So you'd probably be safe to put a 5 amp fuse here, right? If it goes higher, that's going to blow it. You're not going to cause any problems, but you don't want it so low that it's on the verge of overheating or melting the fuse or blowing the fuse, okay? You don't want it what the current draw is going to be, okay? Okay, this is the same thing that's here, okay? All they're telling you is if you know 2 of these, you can use this formula to figure out the answer. All you do is cover up the one you don't know, and you either multiply or divide. Okay? Anybody not understand that? Got it? In a closed circuit, the power source, the power side wire, circuit protection, resistance is the bulb, the power path is the wire. In this circuit, if the battery has 12 volts and the electrical load is 4 ohms, what is the current flow through that circuit? If this is 12 and this is 4,
3.
3.
okay. So you could put 3 right here, right? If you know 2 of them, you can figure the O, all right? All right. Watt's law is a unit of electrical power represented by current of 1 amp per second with a potential voltage, a difference of 1 volt. Formula, W equals I times E. I put it right here, backwards, but it's the same thing. Okay, there's going to be a question on the test where you have to calculate wattage. It's going to be very simple, okay? It's volts times amps, okay? Or E times R, or I times E, I mean. Calculate one, simply cover the unknown unit. To see if you need a multiply or divide, that's all you gotta do, okay? They call this a magic circle. Pretty cool, right?
Yes.
Not as hard as it looks, but that's one of the things that you could use to calculate any of that. Okay, tell me what this is.
1.
Sorry, 1 volt to push 1 amp through 1.
Exactly. Yes, sir. Exactly what it is. Okay. Requires 1 volt, push 1 amp through 1 ohm of resistance. All right. Any question on the test tomorrow? 40.
What is this test for?
What's that?
What is that test for tomorrow?
Wednesday test.
For this?
39 to
39 to 47? So by tomorrow, we will have gone through
8 chapters.
all the way to 47.
Got you.
And if you want to, it would be a horrible idea to do a little work for reading on your own.
On 3 is short to power, meaning short to voltage.
Mm-hmm.
Okay.
say a copper wire touches the frame of the vehicle and cause it can cause a fuse to blow.
If what happens now?
If let's say a voltage wire
Touches the frame of the vehicle?
Uh-huh.
Absolutely.
Okay.
Yep. Yep, sure will.
Because on here, it says it may or may not blow fuse, it doesn't say always, this one says always. Right here on 463, on the short to voltage, it says right before the numbers, a short circuit has the following features, number 6, and may or may not blow a fuse. This one says always causes a fuse to blow. I got my fucking hair braided.
Everybody ready to go?
Yes.
All right.
It requires 1 volt to push 1 amp through 1 ohm of resistance.
Pretty simple.
Number 2, the electrical path to ground may be completed by both A and B.
Vehicle frame or metal body vehicle. Yep, here's an electric path to ground.
Okay, I found out what's happening.
What's that?
Should be.
A sheet metal screw holding a metal body panel has pierced the insulation of a wire and is touching the copper wire. What does this cause?
Short to power.
Is it to ground? It's part of the frame, part of the body.
Ground, yeah, metal part of the body, short to ground. The metal is the ground. Your negative battery cable is connected there.
So it's the body of the vehicle.
The body of the vehicle, the frame is all a ground path. Yeah, because your negative battery cable is connected right to the frame or the body or the engine block or something like that. That is all a ground. Nothing, no power wires can touch any of that.
What can cause a short of power?
I'm sorry,
What can cause a short of power?
a short,
Short of power. Like,
Voltage.
Cause that.
Two wires touching each other.
The two wires.
a short to voltage, you mean?
No, power.
Short to power, they're just
Same.
wording it weird, it's
Same
short to
thing.
voltage.
Same thing, power, voltage, yeah.
A high resistance is a circuit, I put C,
Is it
or if it's not C, is it
A?
A? I put C, but
Okay,
It's B, right?
It's
Did it
A.
blow out your vents too? Did you get stuff flying out your vents?
No.
No?
what?
Okay.
Do I have lube coming out my what?
Nothing flew out?
No.
Just Deborah's? Okay. Deborah had stuff flying out of her air conditioning vent, so,
Oh, yeah, cause he's
Yeah.
up there
Yeah.
changing filters or something.
yeah.
No, I haven't seen anything.
Well, I don't
Thank
think we have
you.
ours on, right?
Probably cause it's not on though.
Once it turns on, it's gonna
That
start
would be
shooting
why,
stuff.
right?
It was on earlier, it's been on all morning, nothing.
Let's turn it on and see if we have stuff flying out the vent. Take cover.
I'll get 'em up under my desk.
Let's see.
Like what would fly out dust?
It's probably just like old lamp and shit.
Yeah, he was in there changing filters. maybe we won't get any.
Starts snowing in here.
Okay,
Is that the heater?
shut up already.
Warm.
Number 4 is A.
Number 4,
Makes everything slower.
where were we?
High resistance.
Okay, we were on 4, right? High resistance in a circuit, okay. What does high resistance in a circuit do?
It
Blows the fuse.
slows down
No,
the current.
you got it backwards.
Slow operation.
Low resistance in a circuit will cause a fuse to blow. High resistance in a circuit reduces the current flow. The more the resistance, the less the current flow. Okay? A, don't confuse the two, okay? Low resistance will cause a fuse to blow, okay? So think about resistance. Okay, what is resistance? It's the resistance to current flow, right?
Yeah.
So if the resistance is high, you're never gonna blow a fuse because you're not getting much current flow, right? If it's low, you get too much current flow, that's when the fuse goes off. Okay? All right, number 5.
Two install wires with the melt together, with the copper conductor touch each other. What type of failure would it be? B?
It's A. Short of to voltage.
Okay, they should have worded this
Different.
a little bit differently. They're talking about power wires, so it's gonna be a short to voltage. Okay? They should have said 2, power wires or whatever. It just says 2 insulator wires. Well, 2 insulator wires could be ground wires. It could be anything, right?
Mm-hmm.
Short to voltage, that's what they're getting at here, okay? All right.
High
6,
resistance.
let's see how you do with 6.
High resistance in a circuit can cause C.
D.
Oh.
Which one?
C?
C?
Yeah.
It can cause C.
D.
But it can also cause all of the other ones. High resistance in a circuit means you don't have enough current flow, right? If you don't have enough current flow, your light's gonna be dim, right?
It's on the bottom right of 464.
Slow motor operation, maybe your power windows are barely moved or something like that, right? Or car won't start.
And top left of 465.
Clicking of the relays or solenoids. Clicking meaning they're not getting enough power, so they're not, the magnetic field isn't strong enough to hold it.
So if that was a lower resistor, that was low fuse, right?
Right.
Then
Uh-huh.
that's why.
A complete circuit.
A complete circuit that is continuous from source through loads and back to ground has continuity.
This is the question I told you not to confuse this word with this word because it is continuity and it's gonna be on the test. Make a note of that on your quiz.
Excessive corrosion on an electrical connector. Damn. On an electrical connector can cause lights to be dim.
Isn't it both? Well, excessive corrosion.
Okay,
Can it cause a fuse to blow?
okay. This is where we need to clarify,
So we'll have to
okay?
do both then.
What is corrosion going to do?
Corrode.
It means you got a bad
Yeah.
connection, meaning you're not getting quite as much current flow as you need, not as much voltage, not as much amperage, right?
Yeah.
You got high resistance.
So
What's
slow
high
connection.
resistance gonna do?
B.
It's definitely not gonna do that.
Yeah. So it is B?
Yes.
Okay, yeah. I was just taking from experience. My old battery used to be badly corroded. So, and it didn't blow nothing, so I knew that was it.
All right.
Resistance.
What is the symbol used for voltage?
E.
E is the one. And number 10.
A.
C.
A.
C.
A.
A. It says always. It says always. It's a may or may not. It's A. I'm confident.
That's what the book says.
I'll read it right
463,
now.
let's see what it says.
463 at the bottom of a short circuit has the following features. Number 6, it may or may not blow a fuse, and it's italic in may or may not.
Yep.
It's
Depending on if it's bypassing all or part of the electrical load. You
Yeah.
can have a short to ground that doesn't blow a fuse. See where that says always it causes the fuse to blow?
yeah.
Nope. Include an open circuit? Nope. It's actually
Neither.
neither one of them.
Oh wow.
What?
Oh yeah, because it's shorted.
Yep.
That makes a lot of sense.
So, this is one of those questions that will make you think, and if you don't think, you will mess it up. This, I'm gonna tell you, is probably gonna show up on the test.
Gotcha.
Don't mess it up. Okay.
Well, you said that's needed.
Yeah.
Yep.
Because it's a shorted circuit, it wouldn't be open because that'd be to a switch.
Is 8C?
8 is B.
Now, Ron, correct me if I'm wrong, but I believe that a circuit is different from voltage, correct?
Circuit is a wire.
It was 7?
7 was A.
Okay, I'm wondering why you don't keep up.
You're talking about, I just didn't hear you.
Okay, I've talked to you about this before. You wanna sit here?
I
You
hear
wanna
you.
sit here?
I think it was a hearing problem.
I'm sorry.
It was a hearing problem, I didn't hear you.
Okay, that's fine, but if you were closer, you might be able to hear better. You're welcome to move, okay? Because I know a lot of times when we get all done, you're asking what ones were that we've already covered. I'm just wondering why you don't get them. So if there's something that you can do to help you out, let's do it. You want to be closer? You can even sit in the front row. You can even sit up there with me if you want. Come on, man, whatever it takes. We need you to do good, okay? I'll help you out any way I can, but if you don't tell me, I don't know what to do. Okay?
Question. Have you ever had a student like sit here for 4 months and not make it all the way?
Nope.
No.
Nope. Okay? Nobody has ever failed the class, okay?
Just dropped out?
I've had to take some people out because they just didn't get it, and it wasn't worth spending 4 months of their life when I knew they were gonna fail. Because it just, after 3 or 4 weeks, I just realized it just didn't click. They just didn't understand any of it. So I just removed them from the class. Has anybody ever sat here for 4 months and failed? No. It's not gonna happen this time either. Okay? So all you have to do is pay attention. If you have a question, ask. If you don't understand something, ask. That's why I'm here. Okay? Don't just go, I don't get that, and then just let us go on, okay? Find out whatever it is you need to know, okay? I'm not here to make this difficult. I'm not here to, to sit here, waste 4 months of your life and you not pass the class. That's not an option. Everybody's gonna make it, all right? And if you need help or whatever, tell me.
So like, is that the wording of like each of them, like this is gonna be on the test, right? So like, this is the word, this is the same thing up there, some of them. So it's just like,
Okay, so what are you looking at?
so it's just like, some of these right here, right?
Yeah, this will be there, yeah. Yep.
And
As we go through this, you notice how I say, this is gonna be on the test, so if you shoot it on your computer, go, okay, leave a little mark right there, whatever. This is gonna be on the test, this is gonna be on the test. So, when I give you time to study for these, right, you'll know, okay, I need to know this, I need to know this, I need to know this, I need to know this. There's no reason anybody should not pass, because these questions are all questions you've seen before. I don't throw anything for any loop.
There's a difference between circuit and voltage, right?
Between a circuit and voltage?
Between circuit and voltage, there's a difference, right?
Okay, circuit
No,
is
I'm just
a-
asking.
Yes,
Okay.
yes.
So a shorted circuit, right?
Mhm.
Because when I looked at this and it threw me off a bit because it was asking for a shorted circuit and the answer that they were coming up with came from a shorted voltage. So I just wanna make sure that when it says circuit, it's circuit, and when it says voltage.
Okay, a circuit is this whole thing.
I know that, but it threw, I take things, you know,
Yeah,
that
I know.
So if the wording is off, I need to be like, okay, well, that's, you know what I mean? So for number 10, assure the circuit, I was looking for that, but then, Joe said, or whatever the other kid's name is, sorry,
Maurice.
Susie, I forgot.
Let the other
I
kid.
forgot. Was looking at assured at voltage, and that just threw me a bit, because it says it may or may not blow a fuse, but I'm like, okay, well, that's voltage, and not
Okay, right,
circuit.
short voltage, right,
Right, and not circuit.
right.
So was I on the right thing looking at circuit and not voltage?
So what
Do
you
look-
should,
am I saying
so
that
you,
right?
what you should have been looking at is your short to ground, right here.
That's what I should have been looking
Right,
at.
because that's what they're asking. Shorted circuit means a circuit that's got a short
Right,
to ground somewhere.
right, but I was looking,
Okay?
like, when.
Now, a
you
short to
said-
ground, again, may bypass all the electrical load or some of it. If it only bypasses some of it, and you don't have too much current flow, it may not blow the fuse. But if it bypasses all of the electrical load, that fuse is gonna snap like that. So it may or may not.
What about shorter voltage?
I'm sorry,
Shorter voltage, would it blow it?
a source of voltage will not blow a fuse normally.
Shorter,
It probably could, but not normally.
only a shorter ground can blow.
Most of the time, yeah.
I have a question.
Yes.
On question 8,
Okay?
a little bit confused. It says excessive corrosion.
Let me see, let me go back to this real quick. 40, is it on the paper? The A?
Yeah, it's
Paper,
40.
number 8.
Okay, A. 8?
Corrosion happens like when you get water in it, right?
Okay, yeah, yep.
So like, if you get water into your, like, if you get water into your electric system, it won't like blow a fuse, it will just make it like dim, like,
Right,
it won't
right.
work as better.
So let me give you an example here. Let's say, let's say we had a wire hooked up to this ignition coil right here, right? And you had a nice, tight, clean connection here. Current's gonna flow perfectly, it's gonna work like it's supposed to work, right? But let's say it's exposed to whatever, water, moisture, you know, whatever, a lot of humidity, and it kind of rusts up, gets a little bit corroded. Then you don't have very good contact here, right?
Okay, and what happens? to
So
the
what
resistance?
happens is if this, let's say this was a light, like it's using that example, that light's gonna be dim, right? Because of that corrosion, you don't have a good connection here. Which means whatever it is isn't gonna work very good until you take this apart, clean the corrosion off, and make sure you got a nice, tight, clean connection. Then everything works like it's supposed to, okay? Corrosion just means a bad connection, okay?
It'd be high resistance.
High resistance, yeah, exactly. Exactly. All right.
More questions?
As many questions as you want. Like I said, this is why you're here. If you don't understand something, ask, okay? I'm not gonna get mad at you for asking a question. I want you to ask. If you don't understand it, please ask, okay? Okay. There's no dumb questions. Everybody's heard that, right?
Yeah.
Okay.
Some are. Time here, but some questions.
Well, you know, if you don't know, you don't know. Doesn't mean you're dumb.
No, I'm
And
not
you
saying
didn't get
that.
it. Okay? Okay. Some of these questions are gonna be on the test too.
An electrical circuit uses 12 volts and has a current of 2 amps, which is a watt of
6.
6 watts.
This question might come up on the test exactly like this.
Okay.
Isn't it 24 watts?
No.
Electrical circuit has 12 volts, 2 amps of current. What is the wattage?
6.
Amps times volts.
It's 24 watts.
Oh, yeah.
Really?
Yeah,
12
24 watts.
24 watts.
Because amps times volts.
What is 12 times 2?
So, yeah,
It
12
doesn't
watts.
get any easier.
We're multiplying, okay.
Yeah.
Isn't 12 volts always 24 watts?
Huh?
Isn't it?
No. Depends on the current flow through the circuit. Okay, electrical circuit has 12 volts and a current flow of 2 amps. It is 24 watts. Look,
Yeah.
watts equals voltage times current. Current, voltage, 12 times 2 is 24.
Yeah.
That question's gonna be on the test. It doesn't get any easier. If you can multiply 12 times 2,
So basically second grade math.
I'm telling you, this is so easy.
You know, this is fourth grade
And
math,
again,
right?
if you
No,
don't
it's
get
second
it,
grade math. I learned
ask me.
division is second
So-
grade.
Say,
No, I'm saying
say,
now.
I don't understand how this works, or something, okay?
Yeah, we're smarter. No offense.
We're in the home stretch of the class, so, again, you guys know who you are if you're on the border, okay? Got to do better. So, if you have problems, you have questions, whatever you want, I'll help you with it, okay?
When
I'll
do you
make
have
sure
to-
everybody gets through this class and shows up at graduation.
When do you have to divide?
Only
into
if there's
watts?
donuts.
If you were looking
Sorry?
for, if you were looking for the volts or the amps, and you had the watts up there, then you would have to do division.
Okay. Let's change this around. So that it looks like it is in the book. It's the same thing, I just got it backwards. Okay?
That's the same thing.
I know, I just had it backwards before. I'm just writing it the other way. I just had volts times amps equals watts. Watts equals volts times amps. This is what they're asking you. This is the actual question. What is the wattage? If you know how to calculate it, you go, okay, well, 12 times 2 is 24. That make sense?
Yes.
Okay.
Already did two, right? No.
Yeah.
Okay. We did this one. If you have a sheet metal screw holding a body metal panel pierce the insulation of wire, and it's touching the copper on the wire,
A, short to ground.
it's short of the ground, right?
3 is A.
Some people mess up question number 3. This one might show up on the test as well.
Is it neither?
So open is
Okay?
no wire like up, right? Not-
Yeah, it's open.
It's up, it's open.
In an open circuit, what is the answer to this question?
I think it's
A.
A.
No current flow, 'cause
No current will flow, right?
it's like this.
Voltage is present, but no current will
Yeah.
flow.
Exactly, thank you. That's the thing people mess up on sometimes. Most of the time, the students will say both. Well, the voltage is still present, the voltage didn't go anywhere. The voltage source is still there, but there's no current flowing because the circuit's open. Right? Okay, if you cut a wire, whatever you cut that wire to isn't gonna work, right? You just created an open circuit. All right. A complete circuit has continuity, right?
A.
Okay.
If 12 volts are being applied.
Here we
to
go with our Ohm's law. You're
resistance,
gonna have to know this.
3 ohms.
4.
Being applied to it.
What is it, Terrence? Give it to us. 12 volts is applied to a resistance of 3 ohms. 12 volts, right? This is your formula.
Four.
C.
What is 3 times 4?
12.
All right. Got it?
Yeah.
Okay. All right.
6 is A.
How many watts are consumed by a light bulb if 1.2 amps are measured when 12 volts is applied?
A.
Is it A?
It's difficult.
What is 1.2 times 12?
It's B, 144.
1.2
That's
times
144
12?
watts.
Oh, 1.2, sorry. Oh, I saw 12 and 12.
Oh,
I'm
yeah.
sorry.
Yeah, 1.2 times 12, 14.4. Whoever said that in the back was correct. Terrence, way to go.
Circuit with excessive current.
No
Like
fuse.
create- Yeah, both.
Both,
A
right?
circuit with excessive current flow. What does excessive current flow do?
It's a lot.
They overreach.
It causes things to get hot, it could cause a fuse to blow, right?
Both.
Both of them, okay? Okay. All right, we're getting it, right?
An open electrical circuit has 0 ohms resistance. False.
It's open.
It open, that means it's open, right? It's not connected.
But it's all about resistance.
Yeah.
It still has resistance.
Yeah, just like we talked about before. An open circuit, still has voltage, just has no current flow, right?
That's false.
An open circuit has 0 ohms resistance? No, the resistance is still there. It's just no current flow, because it's open, okay? Okay,
That's false, right?
yes,
Yeah.
correct.
A circuit with a short to voltage may cause other circuits in proper operation. Both.
Yes, short to voltage will cause other circuits to malfunction because you have power on something that's not supposed to have power at that time. Improper operation of loads in the circuit, for sure. Okay, we did this one, excessive corrosion.
High resistance.
High resistance, lights will be dim if it happens to be a lighting circuit. Okay. We're gonna take a break 15 minutes. We'll come back and do the next chapter.